This video is on the objective, calculate the margin of error for confidence intervals for a proportion. Alright, now this is the second video, number 2 here, on a question that is related to this objective in your Newton-Alta homework. It's very similar to the first one, number 1, so if you saw that video, I'm just going to use the formulas this time. I'm not going to do all sorts of explanations. This should be a little bit shorter. So let's take a look. And as usual, if you're unfamiliar with the topic, you want to see how they're doing things, how they're instructing you how to do things, click on more instruction, read their notes, look at their videos, watch their, read their examples, and hopefully those help. Alright, so here Kendall wants to estimate the percentage of vegetarians who are also vegan. She surveys 150 vegetarians and finds that 45 are vegan. Find the margin of error for the confidence interval for the population proportion with a 95% confidence level. And round your final answer to 3 decimal places. Alright. So here we go. Now I'm just going to, again, when you're doing a confidence interval, when you're doing a CI, a confidence interval for a proportion, right, for a population proportion, the margin of error, right, which is the distance from your sample proportion, your p hat, to the upper value in the interval, and then to the lower value, you would add the margin of error, subtract the margin of error. It is a z-score, and it's a special one. It's what z-score has an area of half of alpha. I'll talk about alpha in a second. Half of alpha above it times the standard deviation for the distribution of p hats. The standard deviation or the standard error for the distribution of sample proportions for samples of size n. And that'd be the square root of, now normally it's p times 1 minus p divided by n, or p times q divided by n, but we don't know p, right? We're guessing p, so we use our sample proportion, our p hat or p prime times 1 minus p hat or times q hat divided by n. All right, so I just need to find these values. Now for this particular problem, our sample size, they said that she took 150 vegetarians and asked how many are vegan. Now remember, typically I'm using the letter X to represent the number of successes, and here being a success is being vegan. So of these 150 people in the sample, 45 were vegan. So the sample proportion, what's going to be in the middle of my confidence interval, is 45 out of 150. And this actually ain't so bad. I can simplify this as 5 times, this is 5 times 9. This is 5 times 30. This is 3 times 3. This is 3 times 10 is 30%. 0.30. And just to double check, absolutely double check my work. 45. Oh yeah, this is 15 times 3. That's 15 times 10. That would be even faster. 150, that's 30%. Fantastic. All right. So we have our p hat. All right, so then this, so I can find this value then, right? So the standard deviation for the distribution of the p hats, right, the distribution of sample proportions for samples of size 150, be this, I'll approximate it as the square root of 0.3 times 0.7, because I don't know p. I don't know p. I'm going to use p hat. Divided by the sample size was 150 here. All right, let's punch this in. All right, so again, make sure all of that is inside the square root. So the standard deviation for the distribution of the proportions is approximately 0.037. But I'm just going to leave that value up there on the calculator. And all I need to find now is this value. Now, in order to find this z-score with an area of alpha over 2 above it, I need to know alpha. Now, that depends on the confidence level. Now, we have a 95% confidence level. And if that's the case, then the value of that alpha is the remaining 5%, or 0.05. So alpha divided by 2 is 2.5%, or 0.025. So what I'm looking for here All right, this value here is going to be the z-score with an area of 2.5% above it, right? So z with the 0.025 subscript. Now that's given in a little chart on the assignment. Z 0.025 is this 1.960, right? 1.960 standard deviations above and below the mean to get you to the upper and lower value of the confidence interval. Yeah, so this is 1.960, and therefore the margin of error is going to be 1.96 standard deviations, right? 1.96 of these 0.037s. All right, so on the calculator, I'm just going to go 1.96 times the previous answer, right? The previous answer was my standard deviation of the proportions. And to 3 decimal places, this rounds to 0.073. There's our margin of error. And then I would add this to 0.3 to get the upper value of the confidence interval, subtract this from 0.3 to get the lower value of the confidence interval if we were asked for a 95% confidence interval here. But we're not. We're just asked for the margin of error rounded to 3 decimal places. So 0.073. And again, please read your answer explanations, whether you're right or wrong. They're using p prime instead of p hat. They mean the same thing. Yeah, the same calculations I just went through. Fantastic. All right, so hopefully this video helps, again, in working on these kinds of questions on this objective. And thank you very much for watching.